Okay, so now that I talked about binomial coefficients, these NCRs, right, and Pascal's pyramid and how it's beneficial in finding these answers, now we're going to utilize this within our binomial theorem to figure out, let's say I want to take a binomial and raise it to the fourth power, okay? Basically, remember, whatever I'm doing, let's say x plus 2, let's say I want to do this to the seventh power. That means it's x plus 2 times itself 7 times, right? So plus 2, x plus 2, x plus 2, right? So basically what I would do is I'd have to take it 2 at a time and do my FOIL, right? So I get x squared plus 2x plus 2x, which is plus 4x plus 4, right? And then I'd get that here. And then I'd get that here. And then I just have this little x plus 2 left, right? Now, basically what I'd have to do is I'd have to then FOIL these, and then FOIL those two answers. And it's all this losing track and all this craziness and forgetting, making sure you're combining like terms. That just ends up being a lot. So there's actually a pattern using summations and our NCR that could come together and figure out what would be x plus 2 to the 7th power without doing all that FOIL. So this is what it is. If I have two terms, okay, now notice how it's a plus, because whatever sign is with it, the A or B, you got to keep it with that. So my A is my first term, B is my second term, N is my power, okay? If I want to know what this binomial to a power is, I'm going to do the sum where my N is my top, and I start with an R of 0, okay? Let's start with an R of 0. And what I'm going to do is I'm going to do N above R, A to the N minus R power, and B to the R power. And you're going to do this for R of 0, R of 1, R of 2, all the way until you hit where your R and your N match. Okay? Now I know that seems really crazy, but don't worry, we're going to get through this. Okay? So let's say I ask you to do x plus 2 to the 4th power. So instead of doing all that FOIL, what I need to notice is that A is my first term, right? Which is x. B is my second term, which is positive 2. And N is my power, which is 4. Start by laying out everything you have. So what I'm going to do is the sum, where I go up to my N, which is 4, and an R of 0. R stays R, all right, because R is what's going to change. Your A, your B, and your N do not change. And then it is your N, which is 4 above R, because your R changes, keep it R. Your A to the N minus R power, so it's X to the 4 minus R power times my B2 to the R power. Okay, now take your time writing this all out. So I got to start with an R of 0, right? So it's going to be 4 above 0, X to the 4 minus 0 power, R to the, or my 2 to the 0 power, right? Now remember, with all the summation, we then put a plus in front, right? So your first term, when you do x plus 2 to the 4th power, will be all of this. Now I'm going to do an R of 1. So 4 above 1 equals x to the 4 minus 1 power times 2 to the 1st plus. Now I'm going to do an R of 2. 4 above 2 times x to the 4 minus 2 power times 2 squared. There is a pattern to all this. The only thing that's changing within this is the R. Plus, now an R of 3, 4 above 3, x to the 4 minus 3 power, 2 to the 3rd, and then last, 4 above 4, x to the 4 minus 4 power, and 2 to the 4th. Okay, now I know it's a lot of writing, but the more organized you are, the better off you'll be. Now, You could do the 4 above 0 and 4C0, 4C1, 4C2, all that. But remember, if you remember Pascal's pyramid, which I have somewhere here. Here we go. If I go to my fourth row, I have 1, 4, 6, 4, 1. So those are all the answers I will get for that little bit here. So 1, 4, 6, 4, 1, right? So I know I'm going to have 1, 4, 6, 4, and 1, right? Now, x is going to be the 4 minus 0 power, which is 4, right? X to the fourth is just x to the fourth. And then 2 to the 0 is 1. Remember, anything to the 0 power is 1. So now 4 minus 1 is 3, so it's going to be x to the third, 2 to the first, which is 2. 4 minus 2 is 2, so it's x squared times 2 squared, which is 4. 4 minus 3 is 1, so it's going to be x to the first. 8 is 2 to the third. And then 4 minus 4 is 0. X to the 0 is 1, because anything to the 0 power is 1. And then 2 to the fourth is 16. So, here are my numbers here. Okay, now what I'm going to do is I want this to be one term. I'm going to multiply everything that I can. So 1 times x to the fourth times 1 is 1x to the fourth, right? Plus 4 times 2 is 8, x to the third. Plus 6 times 4 is 24, x squared. 4 times 8 is 32, x. Then 1 times 1 times 16 is 16. So this is what x plus 2 to the fourth power is. There we go. Now I know this seems crazy and a little difficult, okay? But if you take your time with it and notice the pattern, okay? So I'm going to highlight some things to notice. So it always goes up by 1, right? Keeps going up. Once we hit where the 2 match, we are done, right? Now, there we go. Now another thing to keep in mind, the first term, the power starts at n and goes down to 0, right? And the opposite power starts at 0 and goes up. Something else that you could see as a pattern is that your 2 powers, that looks gross. Your 2 powers always add up to your n. 4 plus 0, 3 plus 1, 2 plus 2, 1 plus 3, 0 plus 4. It's kind of, once you see those patterns and you get the hang of it, it's going to go much faster and you're going to feel great about it. Okay? Just remember, trust me, you know I'm here for you. Though I am not in a classroom teaching this to you, you know you could do this and you can always reach out to me if you feel like you're struggling. Okay? We can do this. Now what I'm going to do is I'm going to do example 3 with you guys, and then we're going to do the checkpoints on our own. So, expand the following. 2x minus y to the fifth. So, my first term is 2x, the whole thing. My second term is negative y. Keep the sign. And my power is my n, which is 5. So, what I'm going to want to do to find out what this is, to find out what 2x minus y to the fifth power is, I'm going to want to do the sum, where I stop at 5, and I use an r of 0 all the way up to 5. I want to do 5 above r, my first term 2x to the 5 minus r power, and negative y to the r power. So, oh my god. Okay, so I'm going to start by doing an r of 0, and then 1, 2, 3, all the way up to 5. So I'm going to do 5 above 0, 2x to the 5 minus 0 power, which is 5. and negative y to the 0 power. Now plus when you go to a new term. 5 above 1, 2x to the 5 minus 1, which is 4 power, negative y to the first, plus 5 above 2, 5, then 2x to the 5 minus 2, which is 3 power, and then negative y to the second, plus 5 above 3, 2x to the 5 minus 3 is 2, 10 times negative y to the third power, plus 5 above 4, 2x to the first power, negative y to the fourth, plus 5 above 5, 2x to the 5 minus 5, which is 0 power, negative y to the fifth. Okay, now that we wrote out all the difficult stuff, now we can go on and simplify things. Now, if you want to use Pascal's pyramid, okay, we know that we have 1, 5, 10, 10, 5, 1 as the numbers within Pascal's pyramid that will give me all my binomial coefficients for 5. Can you not right now? I don't think it would say